Hey guys, welcome back. Welcome to my video, and we're in the map 20 sequences and series units, and the topic is geometric sequences. Okay, so for this unit, guys, there's a bit of terminology we need to kind of keep clear over here. First of all, guys, the word sequence is a list of terms. A series, I guess this term in terms of a math sense, not a thing. A series is a sum of terms. Okay, so mathematically, guys, a series means we're adding terms together. A sequence means we're just listing those terms. Okay, so this is called geometric sequences. Now, before arithmetic, I'm just going to put a little note over here. An arithmetic sequence, a sequence where consecutive terms have a common difference. Okay, so that's what we mean by an arithmetic sequence. Now, geometric sequence, I'll show you what that is. List the next three terms of the sequence. Okay, so we have 3, 6, 12, 24. Now, looking at this, guys, I hope that you recognize that what we're doing here is we are multiplying times 2, times 2, times 2. Okay, so continuing this pattern, 24 times 2 would be 48. 48 times 2 is 96. 96 times 2 is 192. Okay, so this is what we mean by a geometric sequence over here. Okay, now what we mean over here, if I take any two consecutive terms here, so I take this term and this term, if I go 192 divided by 96, I get 2. If I go 96 divided by 48, I get 2. If I go 12 divided by 6, that's this term divided by this term, I get 2. If I go 6 divided by 3, I get 2. If I go 24 divided by 12, I get 2. Okay, so my point is, if we divide a term by the term that happens right before it, we're always going to get this value of 2 for this sequence over here. What we call 2 is a common ratio. So again, what we mean by that is a ratio is when you divide two terms, you compare two terms to division like this. If you have any two consecutive terms, you're always going to get this guy. Okay, so the common ratio, and we use R for in this formula over here. Now, if I look at 60, 48, 192, this one's definitely more difficult, but I'm just going to go, and I'll show you on my other calculator here, guys. Okay, so if I go 48 divided by 60, I get 0.8. I'm just going to go math frac here. So I get 4/5. Okay, so if I go 48, let's back up. If I go 60 times, and guys, if you use this calculator and do it like this, times 4/5, we get 48. If I go times 4/5 again, I get 192/5. If I go this number times 4/5, I get 768/25. Okay, so the idea is if I just multiply times 4/5 every time, I get the next number in the sequence. So my common ratio is going to be 4/5 in this case. Okay, so again, 192 times 4/5. Nope. So 192/5 times 4/5 was 768/25. If I do it again, so I'm going 768/25 times 4/5, guys. I'm just using my calculator for this. I get 3,072 over 125. And then if I do the same thing times 4/5 one more time, I get 12,288 over 625. Okay, so there's my next third terms in the sequence over here. Now, what we're doing over here is we want to be able to derive the general term for the geometric sequence. Now, here's the way we're going to do this. I'm going to give you an example here, and I'll show you how we kind of generalize this. Let's say our sequence is 4, 12, 36, 108, ... That means this would be T1, this would be T2, T3, T4, and I want to figure out what is Tn. Well, how do we get this number? This one was just T1. Well, this number here, let me go back up. So this is 4. This number was 4 times 3. This number was 4 times 3 times 3, or 4 times 3 squared. My next one was 4 times 3 times 3 times 3, or 4 times 3 cubed. Okay. Now, what I want to get at over here, if I'm looking at term 2, it's 4 times 3. If I'm looking at terms 3, it's 4 times 3 squared. If I'm looking at T4, it's 4 times 3 cubed. So what I'm trying to get at, guys, is this number, which is our n value here, and this exponent. The exponent is always 1 less than this guy over here. So what's this guy going to be? Well, it's going to be 4 times 3 to the n minus 1, because the exponent is always 1 less than the term number. Okay, so this is how we do it. Our general term for a geometric sequence is T1 times r to the n minus 1. Often, guys, we see it like this, written like this, T1 r in brackets to the n minus 1. So I'm taking the r to the exponent minus 1 times the first term, and that's how we get our Tn for this guy over here. All right, determine the general term and figure out what T10 is. So if I go take any two consecutive terms, 6 and -2, and if I divide them, I get -3. Same thing here. If I go -18 divided by 6, that's also -3. So therefore, our common ratio is -3. Our first term is T1 equals -2. So our formula, Tn equals T1 r to the n minus 1 is -2 times -3 to the n minus 1, like this. Okay. Now, a couple things here, guys. Make sure that we're not multiplying these guys over here. This exponent is applied to the -3, but it's not applied to this -2 over here. Okay. So this is what we call the general term. This is the general term for the sequence. Now, the second part says use it to figure out T10. T10 is going to be -2 times -3 to the 10 minus 1. I'm going to fire this straight into my calculator. And actually, guys, I'll show you how I'm doing this on my calculator as well. Okay, so for this question, it would be -2, bracket, -3, exponent 10 minus 1, gives me an answer of 39,366. All right, okay, let's take a look at the next one. So first up, guys, our common ratio in this case is going to be 1/2. If I divide the second term by the first term or the third term by the second term, doesn't matter how it works, but it's going to be 1/2 either way. So our Tn is T1 r to the n minus 1. So that means Tn equals 1,500 times 1/2 to the n minus 1. This is our general term. So T10 equals 1500, 1/2 to the 10 minus 1. Calculator time, 1500. I'm just going to go math frac on that, guys. So T10 equals 375 over 128. So there's my 10th term. Okay, similar type of questions that we saw in the arithmetic sequences question, except now this is a geometric sequence. We're multiplying times 2 in this case. Our common ratio is going to be 2, and we need to figure out how many terms there are here. Okay, we're going to use our geometric sequence formula. The term we're looking for, or the term that we know, is 98,304. Our T1 is 3. 6 divided by 3 is 2. 12 divided by 6 is 2. So that means our common ratio is 2. And we do not know what this n value is. That's what we're looking for. So this is like Tn. So we're going to figure out how many terms is this guy over here. Step 1, guys, solve for this. I'm going to divide by 3. So, guys, we haven't really covered how to solve questions like this, but this is an example of what we call an exponential equation. Okay. Now, for all the questions you're going to see in this course, guys, this number here is some power of 2. Okay. So let's go ahead and figure out what that is. And guys, we're just going to be guess and check by this point. Let's see what's 2 to the 10th. 2 to the 10th is 1024. Okay. Let's try 2 to the 11th. Get 2048. 2 to the 12th is 4096, getting closer. 2 to the 13th is 8192. 2 to the 14th is 16384 times 2 again. That means 2 to the 15th is 32,768. Okay, so therefore, when we say it's some power of 2, that power is actually going to be 2 to the 15th. So this means that this number can be replaced by the exponent power. 2 to the power of 15 is 2 to the n minus 1. Now, the idea is, if these guys are equal and they're both base 2, that means this exponent should equal this exponent. That means 15 equals n minus 1. And we add 1 to both sides. 16 equals n. Okay, so that's how this guy works over here. Guys, I'm just going to erase this part over here just so I can have room for the next question here. All right, similar idea for this question here. If I just take any two terms and divide them, so if I go 7 over 49, I get 1/7. Guys, if I would have gone 49 divided by 343, I would have gotten the exact same thing, which is 1/7. So 1/7 is our common ratio. Tn equals T1 times r to the n minus 1. So 1 over 40,353,607 equals 343 times 1/7 to the n minus 1. All right, so next step, guys, will be pretty gross, but I'm going to divide both sides by 343, like this. Okay, because when I do this, I get this answer over here, which is disgusting. This is 1.38412.872 times 10 to the 10th. Okay, so this number is getting ridiculously small. But this point I'm trying to get is this over here is going to be some power of 7, some power of 1 over 7. So I'm going to go ahead and guess and check some power of 1 over 7. Okay, so let's try. I'm going to go, let's try 1/7. Let's try to the 8th. Okay, didn't work. Let's try going to the 9th. Let's try going to the 10th. Let's try going to the 11th. Okay, let's try going something's not right here, guys. Sorry, guys, I made a mistake here. This is true over here, but if I actually divide this by this, I should have gotten the answer of 7.22476.158 e to the negative 11. This guy's going to work, guys. And when we do 1/7 to the 12th, that's what we get. So that means this guy's going to be 1/7 to the 12th equals 1/7 to the n minus 1. Therefore, 12 equals n minus 1, and 13 equals n. All right? Example 20 says determine the geometric mean. Okay, so if you guys remember what from arithmetic mean, all it means is like this is going to be some geometric sequence over here. Here's our first term, here's our last term. I need to figure out what these terms in the middle are. Okay, so if we do this, we're going to use our Tn equals T1 r to the n minus 1. Now, in this case, we know this is 1, 2, 3, 4, 5, 6. This guy over here is T6. That means T6 equals T1 r to the 6 minus 1. So that T6 equals T1 r to the 5th. We know T1 is 12. We know that this is our T6 here. So that means 729 over 256 equals 12 r to the 5th. I'll divide both sides by 12. And guys, I'm just using my math frac. This divided by this divided by this. Math frac gives me this number here. So 1024. So the way we're going to get r here, guys, is we're going to take the 5th root of both sides of the equation here. I'll remind you how we do this on our calculator. So in order to go 5th root, we go 5, math, and come down to this value over here, and this gives me the 5th root. I'm going to go 243 over 1024, gives me 0.75, which is 3/4. So we know that 3/4 equals r. Okay, so now what the geometric mean means is I just need to figure out what those 4 blanks are going to be. So here's how I'm going to do this one. I'm going to go 12 times 3/4, and I get 9. That means this term over here is 9. I'm going to go 9 times 3/4. Leave it as a fraction. We get 27 over 4 times 3/4. We get 81 over 16. One more time, times 3/4 is 243 over 64. So these would be the geometric means for these guys here. Okay. All right. Same idea for this guy over here. We have Tn equals T1 times R to the n minus 1. Here's our geometric sequence formula. So here's 1, 2, 3, 4, 5. So that means this guy here is T5. This one here is T1. So that means we have T5 equals T1. R 5 minus 1 is to the power of 4. 160 over 3 equals 270 R to the 4th. Divide by 270. I'm going to fire this number here, guys. Math frac. We get 16 over 81 equals R to the 4th. So what I want to do here is I want to take the 4th root of both sides of the equation. Here's the thing we need to remember, guys. Hopefully, guys, we're okay that anytime we take the square root of both sides of an equation, we have to go plus or minus our answer. Well, guys, it's the same thing if I take the 4th root of both sides of an equation. When we do that, we get plus or minus 2/3. So there's, in fact, guys, there's going to be 2 answers to this question. Okay, so I'm going to say when R equals positive 2/3, we get 270. And go 270 times 2/3 is 180 times 2/3 is 120 times 2/3 is 80, and then times 2/3 again would give me 160 over 3. For the next part, when R equals negative 2/3, it's going to be the exact same thing, but this one's going to be a negative 180. Negative 180 times negative 2/3 is positive 120, and that means this guy would be a negative 80 like this. Okay, so this is how this works for the geometric means over here. Okay, definitely a trickier question over here. Example 21, we have 5, 3k plus 5, 80 is a geometric sequence. Algebraically determine the values of k. Now, what we want to do here is we need to figure out what the common ratio is. Well, common ratio comes from if I take any 2 consecutive terms like this and divide them, that's going to give me my common ratio. Okay, so there's one way I can get it. Well, the other way I can get it is I can divide this guy by this guy. So if I go 80 over 3k plus 5, well, that also equals R. Okay, so if these guys are both equal to R, that means they both equal each other. So this is going to be 3k plus 5 over 5 equals 80 over 3k plus 5. Okay, so how I'm going to solve this equation here, guys, I'm going to multiply both sides by 3k plus 5 like this. And what that's going to do is going to cancel out those terms there. And then I'm going to multiply both sides times 5. It's going to cancel out those guys here. I'd have to expand this out over here. We get 9k squared plus 15k plus 15k plus 25 equals 80 times 5 is 400. We get 9k squared plus 30k. 25 minus 400 is minus 375 equals 0. And guys, I might be able to factor this one, but I'm just going to go straight to quadratic formula. So guys, when I do this, I get x1 equals 5. Sorry guys, this is k equals, not x equals. So that means that k1 equals 5. And that means k2 equals, and the same thing, just change this to a minus. So these are the two values that we got for k over here, and that's what we had to do for this question here. All right, guys. Guys, I know this can be, I know the last examples were definitely more difficult. I hope they make sense, though, and please come and let me know if you have any more questions about this topic. See you in the next video.